Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you'll get everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And are you struggling to keep up with customer requests and letting errors slip into production? Want to try some of the innovative ideas in this podcast but don't have time? Data Kitchen's Data Ops software allows your team to quickly iterate and deploy pipelines of code, models, and datasets while improving quality. Unlike a patchwork of manual operations, Data Kitchen makes your team shine by providing an end-to-end data ops solution with minimal programming that uses the tools you love. Join the data ops movement today and sign up for the newsletter at datakitchen.io/DE. After that, learn more about why you should be doing data ops by listening to the head chef in the Data Kitchen at dataengineeringpodcast.com/datakitchen. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. Your host is Tobias Macey, and today I'm interviewing Peter Lubell-Doughtie about using ONA for collecting and processing it with Canopy. So, Peter, could you start by introducing yourself?
Hi, Tobias. Thanks. So my name is Peter. I'm one of the co-founders and the current CTO of ONA. We work in the data management space. I have an office in New York, but we're sort of spread around globally with a larger office in Nairobi and Kenya as well.
And so, do you remember how you first got involved and interested in the area of data management?
Yeah, so a key motivation behind my current company is to bring what are standard tools in the commercial sector to the challenges in global health and humanitarian work. This intersected with my personal interests since around 2003, starting with a Stanford undergraduate research grant in finding meaningful applications of machine learning research. And when we started our work at ONA, it became clear that the first step to building ML systems was to get data into a robust data management platform. Sometimes this meant making existing data systems accessible, but more often it was getting data digitized in the first place. And just as often as that, it was getting data collected in any form at all.
So you ended up starting ONA to try and help bring some of these technologies to a broader scale and potentially smaller organizations. So can you discuss a bit about what it is that you do at ONA and how you get the company moving?
Yeah, so our mission at ONA is to improve access to vital services through better data. So a lot of the organizations we work with and the space we work with in the international development, humanitarian, global health space, the tools there are not what we're used to in the commercial sector. They're often building customized systems and sometimes not aware of the latest advances in data engineering and data management platforms. So our products and our services are both offered as SaaS products and as configurable solutions where we might work more in depth with our partners and our clients. The work actually came out of research that all of the co-founders were doing together at Columbia University at the Sustainable Engineering Lab there. And that's where we first started the platform that you now find on our site at ona.io, and also a health systems platform called the Open Smart Register Platform, or OpenSRP. All of this work sort of began in this research lab, and we saw that within that setting, we couldn't really reach our customers. We couldn't take on the types of contracts and build the types of relationships we needed to be successful. So we sort of spun out of that and formed a company. That was it'll be 5 years in October.
Can you give some of the examples of some of the types of customers and organizations that you work with with ONA, and some of the types of problems that they're using your platform to address?
Sure. With larger organizations like the World Health Organization and the Gates Foundation, the problems they have are on a larger scale. So they want something that they can promote as a comprehensive solution to tracking digital health, managing a large set of ongoing data collection problems. We also work with customers on more specific projects where we might apply our platform to a specific use case. For example, we have a partnership working on malaria elimination in Southern Africa, where they use products built on top of our tools to track the vectors of malaria infection and spray houses with DEET, improve the coverage and eliminate the disease. Another sort of specific project we work on is in supply chain management, tracking vaccine supplies throughout supply chain in low resource environments.
And for people who are using your platform, what does the workflow look like for being able to collect data? And what are some of the types of environments that they're working in and the types of information that they're able to collect using your platform?
So we use a generic standard called the XForm standard. And on top of that, a extension we came up with at the Columbia lab called XLS forms. Excel is such a common tool among our users that this has opened up a lot of opportunities for them to both create and share forms amongst each other. This standard supports text, numeric images, GPS points, including dynamic selects where you might have one form that embeds the results of collection that's happened in another form. So for example, you could use one form to collect a set of villages, and then in the other form have a field worker load up that set of villages and then enter additional information about a specific village. We also support generic programming concepts like conditional branching logic and repeat statements. We even had one group of partners that embedded a linear regression system into their form so that they could do rapid diagnostic for TB based on patient symptoms at the time of collection.
And so when people are collecting data using the mobile forms, there's always the potential for either inaccurate data entry or using the wrong data types or skipping fields. So what are some of the mechanisms that you use to ensure accuracy and fidelity of the data that's being collected at the point of capture to prevent integration or accuracy issues further down the analysis pipeline?
Yeah, this is a really important and complex issue in the work we do. I think there are problems here on two sides. One are the technical problems with just ensuring that the data is transmitted correctly. And then there's the social problem of minimizing the incentives to enter inaccurate or fake data and minimizing whether that's intentional or by mistake. The technical piece is rather straightforward. We make sure all of our tools can operate offline, and we synchronize when we get an internet connection. The more challenging part is working with our partners who usually manage their own teams of data collectors and giving them the tools to define and visualize what accurate means in the context of their work. Part of that is having filtered view sets, so an organization can define what an outlier is and use those to remove outliers or highlight outliers and then follow up with their field staff, make corrections. One of the complexities here is that this incentivization to report data quickly, report potentially incorrect data so that they can hit a deadline or a work milestone is sort of an ever-present danger. To do more complex analysis on the data, maybe breaking it down by the field worker who collected it, looking for surprise values in it, performing outlier analysis and other anomaly detection methods. We enabled that through our API and some dashboards that we've built or that we'll build in partnership with our clients so that they can pull data directly out of the collection platform as it's being collected, pull it into R and sort of perform whatever statistical analysis they need to. A related feature that we've had selectively available within the system for a long time, but are now rolling out to the general cloud platform, is a review or approve option so that users can mark what is accurate and attach a comment thread to individual data submissions.
What are some of the potential difficulties in terms of ensuring that everyone is using the same versions of a form, or at least being able to capture the version of the form as metadata when you're doing analysis further on, so that you don't accidentally either mismatch field types or have gaps in the data that you're processing, and then also potential issues with data corruption at the storage level before it gets transmitted or during transmission to the analytics platform?
So on the side of data corruption, we rely on the open source platform Open Data Kit, which stores the raw data on the SD card on device usually, so that if there is a problem in transmission, we still have a record on the device and they can retransmit it, or they can also pull it off of the card onto a machine and then upload the raw files on the machine. So that handles most of the corruption on device issues. With regards to form versioning, we track the version of the form on our server side. So when you are submitting from the mobile application, it's against the specific version of the form that is stored on our server. And then in the management web application, you can choose to export from a specific version of the form. So for example, you might have removed some columns in a newer version. You can export from an older version to see those columns. So a lot of our groups might export from a couple versions and then merge those downstream. There's definitely a use case for doing that merging across form versions in the application. That's not something we've addressed within ONA. We sort of see ONA as its responsibilities around data collection. A data analysis tool, our data warehousing tool, Canopy, is more suited towards that type of merging integration between different versions or multiple data sets.
And when you're collecting data or receiving data submissions, is it primarily field workers with a given organization who might have some form of training in terms of how to collect or represent the data in whatever form is necessary? Or do you also have users where any general user is able to submit information either using the form or into the data platform for being able to scale out data collection where you don't necessarily have as many people available to go around and perform surveys or interviews or anything along those lines?
Yeah, so both of those are supported in the platform. Definitely most of our users, at least the majority, probably closer to 70% or 80%, operate with dedicated field workers who have user accounts and have some sense of what they are collecting on. But you can, as a form manager, you can accept submissions from anywhere. We have had other groups that have done sort of broader population studies. They might distribute a form link through social media and then have anybody submit to it and do the analysis later on after the fact.
And once the data is submitted, what are some of the integration challenges that you have found to be unique or particular to the types of information that is getting collected in these types of environments and these types of use cases?
I think the biggest difference is that we have to be able to do everything offline. Often these field workers are operating in an environment where they don't have access to internet or cell networks. The power might be intermittent. In some cases, the lifetime of an entire project will happen completely off grid. So for a data collection project, you need to be able to do everything offline and have multiple options for syncing data back, and the conflict resolution strategy, which we've touched on a little bit. In the case of OpenSRP, our health systems application, this not only means making the forms available offline, but it also means syncing down to the device all the patient records relevant to a location, as well as vaccination schedules and any related business logic around alerts for them.
And can you walk us through the overall life cycle of data from the point of collection through to storing and analyzing it in your data warehouse and the various systems that it traverses in the process?
Yeah, definitely. So I think maybe starting at a higher level, most of these projects start with a program. There's some sort of set of goals that our partners or our customers have. And then those get coalesced into a data model. Usually it's defined through a form, that is the data collection form, but it also might involve pieces of external data, demographic data, metadata on the length of a visit or the length of an interview that results in data collection. This form is created along with links to metadata on our platform. That then gets synced down to mobile apps. It could be web forms in a call center. It might be embedded in another mobile or web app. And then once it's down on device, field workers will start entering data, will start receiving submissions. They'll come in through our backend API's load balancer, get routed to an API instance. These incoming submissions will get matched to a form ID on our side and a version ID. The raw submission data gets stored in a flat file store, like an S3 bucket, while a parsed version will go into a PostGIS database. And then once we get any data back at all, it becomes available for analysis. So as a manager, you can see it in our web platform. You can see geospatial maps of where the data is coming from. You can overlay that with hex bins or chloropleths. You can group the data by field worker or by the answers to a specific question. A lot of the problems in data collection, they happen while the data is being collected. Now, as a programmer, we're used to being able to enter something into a REPL and getting the output immediately, adjust the way we're thinking about our problem. In the programs we work with, that's often not the case. It's as if you've entered something into a REPL and then a week later you get the result. This is obviously not a good thing. So we want to focus on getting that analysis back to the program managers as quickly as possible so they can adjust their programs and improve the impact they're having.
And when I was doing some of the initial investigation about the work that you're doing, it looks like you're using NiFi as sort of the central routing and integration component for being able to collect the data and then distribute it to various destination points. And I'm curious what your experience has been using that and some of the decision making that went into choosing that as the sort of backbone of your platform versus any of the other available tooling.
So over the years, as we've worked on our data collection system, we saw this common theme where users want some further analysis on top of their data. So it goes into one platform, and then there's a custom web app that's built to process it in some minor way, a custom visualization that's built to display the customized version. The decision to go with NiFi came out of needing a common integration layer from the various data sources that we would connect to. For example, the health data that we're collecting in our OpenSRP system, we often want to view that in line with data that's coming in through ONA. So in past projects, a couple of years ago, we might have built a web service that pulls in these two data streams. But using NiFi lets us have that general data integration layer, which is also accessible not just to engineers, but also to data analysts. And we can turn around our projects quicker, develop templates, and have a sort of organizational wide standard. In terms of the sort of the processing layer, we actually do use Kafka for routing after it comes into NiFi. The decision for Kafka versus Spark or Flink or one of those other tools is that we were more interested in the storage in a topic queue than in doing the complex event processing at this point. And Kafka fit that use case best.
I'm not sure of the timeline, but somewhat recently began work on the Canopy project, as you mentioned, for building an enterprise data warehouse as a destination point for the information that's collected and to provide your customers with a way of analyzing the data. So I'm curious, what was the tipping point where you decided it was worth the time and effort to go through designing and building Canopy versus using some of the off-the-shelf platforms?
Yeah, so what came together here was sort of the maturity of the tooling and a really good partner that we could work with who had a very clear use case. And Canopy, to be clear, is not a custom built application. It's actually a collection of various open source tools. So it's a wrapper around NiFi, Kafka, Druid, Postgres, Superset, and a custom tool we built called Jaceta. Usually it's not using all of these pieces. It's using each for a specific step in the process. So a common implementation that we have might pull in data from multiple sources using NiFi, push that into Kafka for persistence and replay, and load that in the Postgres as a data store, then visualize it in Superset. So as a user, you might see your configuration of a form in ONA, and then you'd see an exploratory visualization in Superset. The rest of it would be opaque to you.
And what have you found to be some of the most challenging or unexpected aspects of trying to integrate those various components and some of the difficulties that you're facing either currently or recently, and a bit about the sort of evolution of the architecture from the initial concept to the current state.
Yeah, I think when we started out, we had our use case was more built around high availability and larger scale data systems. As we worked more with our customers, we realized that that wasn't their immediate need right now. It was positive in the sense that we got to experiment a lot with Druid and actually roll it out in a couple of production environments, so we know it's available as our clients want to scale. But for the immediate term, a simpler data store like Postgres is fine. It also gave us a bit of, I'd say, a discipline on building strict abstraction layers between the ingester and between the data store, so that if we wanted to swap out our data store in the future, that would be built into the architecture. Another sort of challenge we come up with with the clients that we work with is wanting to host everything on site and on your own infrastructure. Working in global health systems, countries often aren't comfortable having health data about their citizens not stored in data centers that they control, which is entirely understandable. So from day one, part of the architecture was to make sure everything would be deployable on site and would not rely on any external services. That meant detailed Docker Compose files, Ansible playbooks, and Terraform plans, so we could easily stand up the full stack with a single command. We're big advocates of automation and infrastructure in code.
Yeah, I definitely agree with that point. And that's sort of the holy grail of any sort of infrastructure project is push button deployment, where you start with nothing and then 15 minutes later you have everything up and running nicely. And so that's a big part of what I do in my day to day. So it's nice to hear that type of concern reflected elsewhere.
Yeah, definitely. And I think we see sort of the next step here. We can now do this where we might customize configuration files, but obviously there's a meta tool that can be built around this, where your deployments turn into configuration files, and those configuration files get translated into a country-specific Docker file, Ansible playbook, and Terraform plan. So we're sort of looking towards the future and building that out.
For people who might be considering using Canopy in their own environments, what are some of the either pieces of advice that you would provide or notes of caution that they should be thinking about that might dissuade them from using Canopy or encourage them to use it given a particular set of use cases?
Definitely, the stronger you understand your problems, the easier it is to get the full benefit out of the solutions that are out there, right? A lot of that might involve also, coming up with a draft of what your problems are, what your use cases are, and reevaluating those problems as you learn about the existing use cases, and then trying to break down your problems to see whether there is, a single platform that can solve the challenges you're facing, or whether it's an amalgamation of a couple solutions. I think one thing to also keep in mind is that the more you can break down your problems into sub-problems, the easier it will be to find solutions that have alternatives, so that you can either grow as a sub-problem shifts and there's another alternative that you can use that solves it in a better way, or if there's a competitor that becomes available and that ends up being a better solution for that sub-problem. So the modularity, the flexibility, the extensibility within the challenges you're facing is important to keep in mind and clarify as much as possible.
What are your plans for the future of ONA and Canopy and some of the goals that you have going forward?
Yeah, so the technical vision and both the mission behind what we are doing has always been to get to the point where we're using the information that's received through our platforms to automatically improve and optimize programs as they are in process. One example of this is when working with a nutrition program in Somalia during last year's drought, we saw that food distribution sites were based on where the security situation was safest and not where there was the greatest demand for food. So, currently the way things are set up, that's done by visual inspection. You can see on some geospatial maps pulling in from our data collection platform, that these circles don't line up. But in the future, we'd like that type of insight to be generated automatically so that it can create notifications or alerts, and a program manager can use that to refine their programs and have greater impact. So closing that circle between data collection, analysis, and improvement.
And are there any other aspects of the work that you're doing with ONA and Canopy, or the area of data collection and sort of humanitarian data efforts that we didn't discuss that you think we should cover before we close out the show?
Not particularly. I guess I'd just like to add that there is a lot of interesting work going on in the humanitarian and global health sector that a lot of us in the tech world don't get exposed to that often. It's a very interesting place to sort of see the limits of tools that we built for an environment that's always connected, always powered. And some of those limits really expose new problems that can lead to insights and improve sort of the state of technology globally. So it's been a very interesting experience for me to get involved in this area and have my conceptions about how the technology that we use every day works be challenged.
Yeah, it's definitely easy to overlook some of the different ways that data is generated and collected and the ways that it's being used, because there's so much attention being paid to big data and fast data and things moving at high velocity and high scale, that it's easy to forget about the fact that there are a lot of interesting challenges with small granular data, issues with data integration and data cleanliness for sort of distributed data collection and some of the various problems that go into that. So yeah, I definitely second your point that it's easy to get stuck in tunnel vision of what the sort of a certain segment of the tech population is discussing, that you become blind to some of the other areas that our skills and technologies can be put to use.
Yeah, we often joke that we focus on fat and short data compared to big data where you have a couple of columns and millions of records. A lot of our data sets are hundreds of columns and thousands of records. So it's a different use case and a lot of interesting challenges there.
And for anybody who wants to follow the work that you're up to or get in touch or about anything we talked about here, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
The biggest gap that I see is automated systems to merge and integrate different schemas. A lot of the problems we have are similar data sets with different schemas that we want to see in a unified way. And right now, those are combined on an ad hoc basis. Sure, we have the ontologies, the ideal data dictionaries, those all exist out there. But on the ground, in the computer systems that are distributed throughout the world, that's not what the data looks like. And to really scale impact and data integration, an automated schema merging tool is going to have to be built. We're looking forward to integrating that and helping build that in the future.
All right. Well, thank you very much for your time and for telling me about the work that you're doing with ONA and Canopy. It's definitely an interesting problem space, and it's good to see that people are focusing on that. So thank you for your time today, and I hope you enjoy the rest of your evening.
Thanks, Tobias. I was glad to be on here. Thank you for having me.